Maximum elongation of a spring. Let us try this problem. So we have a pulley and one side of this pulley is attached by a spring of a spring constant K. Another side we have a mass M, and initially this spring is unstretched and mass of block is given M. Initially there is no stretching in this spring. This means somebody is holding this mass, and then it is possible. So this mass is held by somebody. Now the person that is holding this mass, if keeps his hand away, this mass will fall in the downward direction. So if mass will fall in the downward direction, a spring will have a stretching. So spring will be stretched and this mass will fall in the downward direction. A time will come when the stretching will be maximum. Let us say maximum stretching is x max, and this mass will have zero velocity. That is, at the time of maximum stretching, this mass has no velocity in the downward direction. So important point we have, at the time of maximum stretching, block will have zero velocity. This can be verified logically also. If it has some velocity, then it will stretch more. Then this is not the maximum. So when this is maximum, this velocity will be 0. Now we can solve this for x max by applying energy conservation. So let us say initially this is the reference point. So this is reference line. Now from reference, this mass has fallen by a distance of x max. Because whatever length of this spring is stretched, it will go in this side. So we can write energy conservation, that is gain in potential energy of a spring is equals to loss in potential energy of mass M. So gain in potential energy of a spring is half k x max square, and loss in potential energy of this mass is mg x max. So from here we can write x max is equals to 2 mg by k. So this is the maximum stretching we will have for this mass.